A discrete random variable might have a probability histogram that looks something like this. The possible values of the variable are a finite set or a countable set separated by fixed amounts, and probabilities are represented by areas under the histogram. So if we call this value A and this value B, then the probability that the random variable is in the range A to B is the total area of the bars over the values A through B. You've also seen that sometimes we might want to draw a smooth curve over the histogram for the purposes of approximation or to somehow better understand how the discrete histogram is behaving, the classic example being drawing the normal curve over a histogram of a random sample sum. But we might now want to consider that smooth curve as a distribution in its own right. If the total area under the curve is 100%, then it's natural to think of it as a probability distribution where now the possible values are not a finite set, but they are all the possible numbers on the number line, or all the possible numbers in some interval. And probabilities, by analogy, we can try to represent by areas under the curve. So you have the point A and you have the point B. You can try to represent the probability that your random variable is in the interval A to B, and now we include every single point in the interval A to B, by the area under the curve between A and B, which is, of course, an integral. So if this function is called f, then what we have said is that the probability that your random variable is in the range A to B is the integral from A to B of the function f. F is called the probability density function of the random variable x. You've seen the density scale for histograms, and we're going to be spending quite a lot of time talking about what density means exactly, but for now, for a function f to be the density of a random variable x, it must satisfy three conditions. So x has density f if, notice that I'm being lazy, I'm no longer saying probability density, just as we say distribution but not probability distribution. So three conditions have to be satisfied. F has to be non-negative. That's a very natural condition. Its total integral over the entire line should be 1. In other words, the total area under the curve is 1. So it's a probability distribution, and crucially, the connection with x is that for all A and B, the probability that x is between A and B is the integral of the function f between A and B. Now there's going to be a lot more detail to talk about. what if the inequalities were strict, and so on and so forth. And all of that is going to be very easily dealt with. But first, let's get used to smooth curves representing probability distributions and to working with them.